Okay, everyone, we are now into section 1.2, combining functions, shifting, and scaling graphs. So in this first example in this section, example 4 of the course, we're going to consider two functions. F of x equals the square root of x, and g of x equals the square root of 1 minus x. So of course, let's first of all think about each of these separately, and considering the domain of f of x. So remember, whenever we have a square root function, we can only plug positive values into that. So the f of x equals the square root of x, we can only substitute any value between 0 and infinity. Of course, we can include 0, but we never include infinity. The domain of g of x may be slightly more complicated. We need this guy to remain positive. So you can either think of it as 1 minus x must be greater than or equal to 0. Solve that for x, you get x has to be less than or equal to 1. Okay, so then that tells us that the domain of g of x is all values of x from minus infinity up to and including x equals 1. Now when you want to think about combining functions, these are the typical operations. F plus g, f minus g, g minus f, f times g, f divided by g, or g divided by f. The domain of all such operations is the intersection of the domain of f and the domain of g. In other words, where do their domains overlap? The only thing you have to worry about is you can never divide by 0. So in these cases where I'm dividing by g and I'm dividing by f, I cannot include any value of x that would make the denominator be 0. So looking at these, the domain of f intersecting with g, so in other words where they overlap, is between 0 and 1, including both 0 and 1. So for all of these simple functions where we're never dividing by anything, I just want to combine them this way, then the domain will always be between 0 and 1, including 0 and 1. Once I divide by one of the functions, I'm dividing by g. So g of x was the square root of 1 minus x. Thus, I can't have x be equal to 1 because I would have 0 in the denominator. So it's still 0 to 1. We just cannot include 1. And likewise, if I'm taking g and dividing it by f, that means that I have the square root of x in the denominator, so x cannot be 0. So that domain would be from 0 to 1, not including 0.